Okay, ladies and gentlemen, we're back to finish up the back side of 1.6 notes. Again, we were talking about proofs. So again, remember the purpose of a proof is we're going to be given two statements and using our theorems like reflexive, alternate interior angles, and so on, we will prove that another statement is true, okay? All right, so here, for example, problem number 5, we're given that angle I is congruent to angle K. We're also given that angle IHJ is congruent to KJH. So here, this is one of those ones where I told you that sometimes your givens can be in more than one statement. So our first reason is given, and our second reason is given, okay? So now we need to mark our sides. So we told the angle I is congruent to angle K. Now remember I told you guys before about how the angles, when it's only dealing with one letter, it's fine to just say angle I and angle K. But when the angle's in the middle, which we'll get to in an example number 6 and number 7, we can't just say angle I, angle K. We got to say all the letters because, again, it can be confusing with just by saying angle I when there's only one angle I here. But on some subsequent problems or future problems, we're going to have more than one angle, okay, with the same letter. All right, so then our next one is IHJ. Okay, we're going to say that IHJ is congruent to KJH. So again, we're just given that information. We don't have to say whether or not it's vertical or alternate interior angles or anything like that. We're just given that information. I'm sorry, mine's a little further spaced out than I want it to be. So let me just correct that real quick. Okay, that's a little bit better. All right. So statement 3 is, again, they share a side, right? So we're going to say that HJ is congruent to HJ. Sorry about that. Let me draw that a little bit better. So because they share a side, those same letters are congruent for both triangles because, again, they're the same, okay? So then that's, again, reflexive. So now let's label our triangle. We're going to go to the top one this time. We got an angle, and a side. So that's AAS. All right. So guys, it's very important. Look back at your previous notes. Ladies and gentlemen, look back at your previous notes and use your congruence theorems because, again, on the test, you're going to have to be able to identify your letters and put them in the correct order. Okay, because it's multiple choice, so I can't give you any partial credit like I did on the quiz, where if you got the letters you got the right letters but in the wrong order, then I can give you partial credit because you had the right letters, but I can't give you partial credit if you don't have the right on an ABCD question. All right, let's look at number 6. All right, YZ is parallel to BC, so we find YZ, which is up here. We draw our first triangle. And then BC, we draw a second triangle. All right. And then A is the midpoint of YC. So that means we're going to draw a congruent line there and a congruent line there. All of this is our given because it's our first statement, okay? Next, we're told that YC is congruent to, angle Y is congruent to angle C. Now, we're told this because look at what it forms. It forms a Z, okay? I'll kind of draw my Z here. So you see what I'm saying? So it forms your Z. So that means angle Y and angle C are alternate interior angles. So you're going to say alternate interior angles. All right. Then we move on to number 3. All right, number 3. Look at when we said that was the midpoint, remember we divided it into 2 equal or congruent sides. So we're going to say YA is congruent to AC because that's the definition of midpoint. Now here the reason was given, so that should have been your clue to go back and see which order you put it in. Now we do need to go in a certain order, guys, but in a true proof, the reasons between your given and your approved statement should follow logical order, but if I was grading on it, as long as it made sense, I wouldn't have a problem in what order you put it in, just so long as it made logical sense. All right. Then if you look at it, we see something. If you turn your head a little slightly, you'll see something Mr. Harper likes to wear on his formal days. Our bow tie. So I'm going to draw the two lines here. And remember, because A involves multiple angles, we can't say angle A. It's congruent to angle A. So again, it doesn't matter the order you go in, but we're going to go in this. But your middle angle must always go in the middle. Your vertex must always go in the middle. So we're going to say YAZ is congruent to angle CAB. And that's, again, our vertical angles. So now let's label our parts. We have an angle, a side, and an angle. So that's ASA. All right. Now let's do our last one. GI is congruent to KI, and HI is congruent to JI. Again, this is our given. So now let's mark our parts. So we said side GI is congruent to KI, and then HI is congruent to JI. All right. So the next thing is you look at it again, turn your head to the side. You see we have some vertical angles. Okay. And remember, we can't just say angle I, and remember the I has to go in the middle, just like it's in the middle of your bow tie. It has to go in the middle of your angles. So our first one is angle GIH. Let me draw that and write that a little better. Sorry. Angle G. Harper can usually write better than this. GIH is congruent to angle KIJ. Because remember, I told you it has to go in the middle. And again, this is vertical angles. All right. So now we need to mark our angles and sides. So we have a side, and an angle. So again, that's going to be SAS. All right. So that's 7 examples of problems you may see. Please work on the practice problems to follow. Use this as a guide to help you solve those problems. And if you have any questions, message me through Google Classroom or through Remind. I'll talk to you in the next one. Bye.